On this video, we're going to graph a system of inequality equations. The first equation is 2x plus 3y is greater than or equal to 15. To graph it, we're going to use the line 2x plus 3y equals 15. The second equation is 4x minus 2y is greater than or equal to 12. Again, we're going to change it to 4x minus 2y is equal to 12 to get the line, and then we're going to figure out which half of the coordinate axis or which half of the plane is going to solve the conditions of the inequality. So again, the first thing we do is we change the inequality equation to y equals mx plus b. We're going to solve for y. So for the first equation, 2x plus 3y equals 15, subtracting 2x from both sides, we get 3y is equal to negative 2x plus 15. Dividing each term by 3, we get y is equal to negative 2/3 x plus 5. For the second equation, we have 4x minus 2y equals 12. Subtracting 4x from both sides, we get y is equal to a negative 2y, is equal to a negative 4x plus 12. Dividing each term by the negative 2, we get y is equal to 2x minus 6. Listing both the slope and the y-intercept for both lines. Since the slope is a fraction for the first equation, I'm going to write that as a decimal number. So we have is equal to a negative 2 divided by 3, and we have that in decimal format. The y-intercept is a positive 5. For the second equation, the slope of the line is a positive 2, and the y-intercept is a negative 6. Now, I want the lines to be very long so we can see what the lines look like on the coordinate axis. So I set the x coordinates to go from a negative 5 all the way down to a positive 11. We're going to find the corresponding y coordinates for each one of the lines, setting up the equation. For the first equation, we have y is equal to a negative 2/3 x plus 5. So we have y is equal to a negative 2/3 fixed cell, which means it's F4 on a PC, Command T on a Mac, times the x coordinate, which is negative 5, plus b, again fixed because we're always going to add 5 to that product, F4 for a PC, Command T for a Mac, and we're told that when x is a negative 5, y is 8 1/3. Now we want to find out the corresponding y values for when y goes from a negative 4 to a positive 11. We just have to copy the formula all the way down. And notice when x is 6, we have that y is equal to the negative 2/3 times 6 plus the 5, and that gives us the positive 1. Now we're going to do the same thing for the second equation. We're going to create our formula in order to calculate the corresponding y values when x goes from a negative 5 to a positive 11. Again, we have y is equal to 2 times the, and remember we want that a fixed cell, F4 or Command T, times the negative 5 plus the negative 6, again F4 or Command T. We want those to be fixed cells because the m and the b are constants. So therefore we have when x is a negative 5, y is a negative 16. Again, we're going to scroll this down so we get the corresponding y values from a negative 4 to a positive 11. And again, this time I'll go what happens when x is equal to 2. We have 2 times 2, which is 4, plus the negative 6, and that gives us the negative 2. Now we're ready for graphing the lines. So again, we're going to highlight the x and the y coordinates for the first line. We go to Insert. We are going to go to our scatter plot with a line, and now we have the linear equation, the linear graph. And we take a look over here, and since y is going to be greater than 2x plus y is greater than or equal to 15, If we substitute the ordered pair 0, 0 for that, we notice that the region above this particular line, this half plane, will satisfy the conditions of the 2x plus 3y has to be greater than or equal to 15. Or y is greater than or equal to negative 2/3. Looking at the y-intercept, y has to be above that. Now we want to put in the actual equations. So we're going to right-click. We're going to go to Select Data. And right now I'm going to edit the first equation. I want it to read 2x plus 3y is greater than or equal to 15. Everything stays the same. We press OK. And now I want to add in the second equation. And I want that to read 4x minus 2y is greater than or equal to 12. I click on the series of x, which means I'm going to scroll from a -5 to a +11. I want to put all the y values in that window. And again, I don't want anything there. So I scroll down from a -16 to the +16. I press OK. And there I have the equations. And this is what the graph looks like. Looking at the orange line, and let's put that there, we see the legend. The 4x minus 2y, again, we go to the inequality equation that has to be greater than, and the point 0, 0 is not greater than 12. So we see that it's this particular region that will be greater than or equal to 12. So we're looking at the region below the orange line. We're looking at the region above the blue line. So this area between the orange and the blue is the region that satisfies the conditions for both inequality equations. Now I'm going to attempt to show you how to draw that. So we go to our insert, and this time we're going to insert an illustration. We're going to go to our shapes, and we're going to go to our freedom shape. Now comes the hard part. You have the plot area. I'm going to start at the point of intersection. I'm going to go up a little bit, click on there. I'm going to go down as best as I can, click over here, go back up, let go, and that's approximately this particular region that will be satisfies the conditions of both inequality equations. And we can pick a point that's over here. Let's say we take the point when x is 6 and y is 2. 2 times 6 is 12, plus 3 times 2 is 6. 12 plus 6 is 18. That's greater than 15. It also works for 4x minus 2y, and we've satisfied that condition. Let's quickly go to sheet 2. We have 3x minus 2y is less than 12. X is greater than or equal to 2. So we're graphing x minus 3y equals 12 in standard form. Y is 1/3 x minus 4. X is equal to 2 is a straight line. That tells us the slope of this line is going to be equal to 1 divided by 3. The y-intercept is going to be a -4. And all I'm going to do is, again, write the equation. So I have y is going to be equal to 1/3 fixed cell times the -6 plus the -4 fixed cell. And I'm going to copy this formula down to as far as I'm going to go, which this time I'm going up to 20. For the second equation, x is always 2, and I'm just going to put in numbers for the y. Let's say I take a -6, a -4, a -2, 0, 2, 4, 6, 8, and 10. And let's see how this works. Let's try it. We're going to take again all the coordinates for the first inequality equation. I'm going to go to Insert, go to my chart, and this is what the line is going to look like. Right-click. I'm going to select Data. I'm going to edit the first equation. I want it to read x minus 3y is less than or equal to 12. For the second equation, I'm going to add, I want it to say x is greater than 2. The x values, and I think I'm going to have to cancel this. I'm not going to be able to get to it. Okay, let's try it again. Press OK. So I'm going to keep what I saved. Let's put that there. All right, one more time. Right-click and select the data. And I have add x is equal to 2. For my x values, I have only 2. For my y values, we're going from a negative, let's try it again. Series name, x is greater than 2. X values over here. Let's get the y values from negative 6 to 10. Press OK. We have it looking like this. So there we have the straight line. I want to be able to put in the legend. And there is my trend line. And since x is greater than 2, we are going to go to the right. And since x minus 3y is greater than or equal to 0, we take 0, 0, which is going to be true. So it's above. So this region between the two. And again, I'm going to insert an illustration, a shape, the free area. I'm going to start over here and do the best I can to draw a straight line, and it's not coming out as well as I would like. Click over there, and let's try this again. And of course, when you're going quickly, everything takes longer. Let's try it one more time, and we scroll down, click here, go across, go up, go like this, and we have a region that looks something like that. It should be in this area over here. So this is the region that will satisfy the conditions for this inequality equation.